derivatives in arc length. I think you'll find this fun. It's like the public service announcement. This is our last lesson from the book for the year. Woo! Yeah, I'm not following the book for vectors, so
That means the rest of the homework is AP multiple choice and free responses.
we'll be doing some spiraling from the book, but no more lessons. Okay. Yeah, I know, we're almost there. Almost there. Okay, area yesterday, we will practice that quite a bit because it shows up about once every 2 years on the free response. Well, let's look at arc length. It's very similar to the parametric form. There's just a little bit of a twist on it. And I think so. Okay, so remember the parametric form of arc length had x prime of t here and y prime of t here. So all you really need to remember is the difference there. Okay, the difference comes because polar is a radial or circular coordinate system, obviously. So we got to be a little bit more careful with a different equation. So let's see what it's got. We call it an arc because polar is a circular coordinate system. So what shape is that I just put on the board? Yeah, it's a circle, okay? What's the radius? Close. It's 1. So the circle diameter is 2, right? Isn't that how we've been graphing this? Let's check. Just to make sure. Because polar. Graph. Yeah. So if you were to graph this, there's your circle. So it sweeps out an area to its diameter. So arc length would be easier to use this or geometry. Yeah, you know what circumference of a circle is, right? Okay, so when you have a chance at this, bail out. What's the circumference of this circle? 2 pi r. 2 pi r, so it should be pi, right? Okay, now we do the hard of it. Okay, what are our limits? where does it start to repeat? So what's the value that's, where does cosine start to repeat? What's the period of cosine? What? 2 pi. Yeah, so we need to go from 0 to 2 pi. This will be 0, pi, 2 pi. So remember when you're plotting these, if I plug pi in, cosine pi is -1, so our radius is -2. So we have come around here to pi, but my radius is -2. Right? So it jumps on the other side of the y-axis. So we do need to do one full circle. What is the derivative here? -2 sine theta? Oh, this is good. This is good. Just gonna call it right now. Anybody know what the answer to the inside is? Wait. 4.
And then.
It's 4. It's 4. Square root of 4 is 2.
Cosine squared plus sine squared is 1.
Yeah, that's what I was gonna say.
Yeah, so cosine squared and sine squared is 1 times 2. Something's not right here. We're gonna get a different answer.
That's because it's minus.
Oh, yeah. It should be negative
Negative sign.
sign.
Because the
Where?
square should be outside of the sign. Or the,
No.
Negative
We're
should
still
be
good.
outside.
We're still good.
Right? That's interesting.
Wait, give me a second. 9.
Am I sure that radius is 1?
because I thought your,
You said radius was on this one.
radius should be the first, the value right before the, first line.
Yeah, I think. They did. Which one are we on? I did slightly different. Why did you do that?
Was it user code? Oh, because, yeah, it's like in zero, you get one.
Zero is 1.
Was that one?
Yeah, go out to two. Isn't that where you start?
Oh,
And then you go to five.
oh, yeah, you're right, actually, my limits are wrong. Okay, check yourselves there. Our integram limits were incorrect. Good call, Mr. Pascal.
What are they then?
0 to pi.
Yep.
Because if you look at 0, 2 cosine 0 is 1. So the answer, the radius is 2. It starts here. Okay. Then we move to, let's say, pi over 2. That value is 0. Right? That will be here, and then pi is -2, so that would bring us full circle.
Okay.
Okay, so we got it figured out. Nice work. Okay, and then let's look at, so again, sometimes these are very easily doable, sometimes it's just a calculator problem. So Keep that in mind. Okay, derivatives. So if you want to calculate the slope of a tangent line in polar coordinates, it's just like parametrics in this respect. Okay, we take dy d theta, dx d theta. What that ends up being is this formula here. Times sine theta plus r cosine theta. It's a little bit of a mess. At the bottom, you can see it can be a mess, right? Is that, wait, I might switch those. Yeah, it should be cosine minus sine, sorry. I'll have these memorized again someday. So if you want to calculate the slope of the tangent line, there's your beautiful formula. Yeah, I know, right? If you look at this, you can kind of see the coordinate system embedded in this formula. That's what it's generated from, because x is r cosine theta, y is r sine theta, and things just kind of work out this way. So let's take the curve r equals 2 sine theta, and we want the derivative at 3 pi over 4. So, all right, let's follow our formula here. What is dr d theta? 2 cosine? And then, should we substitute r in or in a similar way? Go ahead and substitute. Look at that, thing of beauty, right? Sure. Nah. Okay, now we just plug in theta. So we don't have to mess with simplifying or identities or anything here. As long as all these are thetas, plug it in, use your unit circle. Okay, so what is cosine at 3 pi over 4? Negative root 2 over 2. Sine is root 2 over 2. Right? Plus 2 root 2 over 2 times negative root 2 over 2. Add them all. Sorry? What'd you say?
The bottom part is like.
Yeah. I see.
There's no problem.
So what is this? -1. So not ugly. What's this one? Positive. And what does that mean? What does this mean for slope of the tangent line? Undefined, so it's a vertical line, yes. It's just a vertical.
It's basically something that needs to be implemented.
No, I did a different example.
So
So the book did sine 2 theta.
That exact thing, negative root 2.
It would make a mistake. Not uncommon here, because, okay, the derivative of this is 2 cosine theta, right? So I put that in, right? It's sine theta, cosine theta, r is 2 sine theta, cosine and sine. Okay? And at 3 pi over 4, this is negative root 2 over 2, right? 2 over 2. Yeah, you're right. This is the derivative. So
What's on the other side?
what other side?
No,
The other part.
Here, that's just r. Okay. 2 over 4 is 1/2, let's do -1. -1. 1 minus 1. I don't see the error. Yes.
Be negative 1 minus 1.
it's under 2 negatives.
Negative and negative. What's the graph of this look like? What's the value of 3 pi over 4? Root 2? Yeah, I think we're right. We'll check your calculator.
Oh,
Already
it's,
against the wall.
it's in forward, it's in radians.
Let's, yeah, you guys can get to work. You have the work, right? We gave it to you yesterday for this section. You have all of it. Okay, so you can take your time and get some stuff done.